Lesson 10.5 is all about tangents. A tangent is any line that touches a circle or any other shape once and only once. So if I take my circle here and I see that I have a line L, and line L touches my circle one place, I can say that line L is tangent to circle S if and only if, so there's my funny looking if, L is perpendicular to ST, which is the radius. So basically a line will be perpendicular always to a radius. So here's another theorem that we have. And this one involves two lines, two tangents. And what this says is if AB, this tangent line over here, and CD are tangent, what happens then is if they are both tangent to circle D, then obviously they both touch it and they both have point B in common, so because of that they are both going to be congruent. So then these would be congruent. Okay. Now this next part, this is actually example 1, these tangent lines, and we're going to show how many common tangents there are between the circles. So this first set of circles, I have one and then the other one intersects it, and this is going to have two common tangents, and we're going to draw those in. Okay, I'm going to take my blue pen and I'm going to draw one of our tangents is down here, touches the circle in one place, and the other one is along the top, like that. So I have two lines there. Okay, I'm going to go down from there, down to this picture where I have two circles, but they are just touching each other barely. This is going to have three common tangents. So I'm going to have one right between the circles, right where they touch. There is a line that can be drawn between there. And then I can have a line up top. There's a tangent line. And I can have a line on the bottom. There's another tangent line. Okay? Let's come up here to the two circles that are not touching each other. These two circles, between them, they will have four common tangents. These four tangents, one of them kind of goes in between like this, kind of diagonal, and then there's one that goes between it going the other way, so it makes like an X, almost like that. There's two of our tangent lines, and then the other two lines are just like before, one up top and one at the bottom. There's our four lines right there. And try to get it so that it touches just once. Our next picture, we have a circle inside of a circle, but it does touch somewhere. So this only has one common tangent. And that tangent is right here along the bottom. That's the common tangent. And our last picture, these are concentric circles. Remember, circles inside of each other. And since they don't touch each other at all, they cannot have a common tangent between them. So no common tangent there. Alright, let's turn the page and let's talk about example 2. Okay? Example 2 says that we have this triangle that is sort of coming out of this circle, and we know that KL is a radius, and we want to know if LM is tangent. So to know if something is tangent, our first theorem said that if it's tangent, then our radius and our line will be perpendicular. So this would have to be a right angle. If it were a right angle, we could do Pythagorean theorem. So let's use the converse of it, and let's prove that it's a right triangle by using the Pythagorean theorem. So let's say 20 squared plus 21 squared. We're going to see if it equals 29 squared. If it does, it's a right triangle, therefore KL and LM are perpendicular, therefore LM is tangent. So we've got 400 plus 441 equals 841. Okay, is that true? Does 841 equal 841? Yes, it does. So, by converse of the Pythagorean theorem, that means angle L is 90 degrees. Okay? Which means that KL is perpendicular to LM. Therefore, LM is tangent to circle K. Okay. Let's do another one like that. This is another similar example, so that's why it's also called example 2, because it's very much the same thing. So in our picture here, we know that WE is tangent, so we know that this is a right angle. And so we need to find X. So if it's a right triangle, we can use the Pythagorean theorem again. So let's go ahead and do that. DE, how long is DE though? It's going to be X plus 16, that whole length. Okay? So let's use that when we do our Pythagorean theorems. Pythagorean theorem says X squared plus this side, 24 squared, equals X plus 16 squared. You are going to have to FOIL out X plus 16 squared. So we've got X squared plus 576 equals X squared plus 32X plus 256. Okay, let's, usually if we have a squared or a quadratic, we need to set it equal to 0. So minus X squared. Hey, but then they cancel. Those cancel. So let's bring the 256 to the other side. $320 equals 32x. What is x going to be? 10. Excelente. Alright, number 3. AC and BC are tangent to Z. Since they both are tangent and they have C in common, theorem 1011 says that they are congruent. So because they're congruent, to find x, let's set them equal to each other. 3x plus 2 equals 4x minus 3. Okay, let's solve for x. Minus 3x. Add 3. X equals 5. Okay, last page. I'm going to use 3 different colors so that you can see all of the all that I'm going to write. Okay, this uses theorem 1011 also. Now, theorem 1011, remember it says two lines that are have a point of tangency are congruent. So if you look at our shape, we know that QL, this line over here, QL, it is going to be congruent to QN. Okay? So how long is QL? QL is also 2 centimeters. Okay? Now that same theorem, we're going to use it over here. RL is congruent to what? RM. Yes. So these two sides are congruent. And our last pair, SM, this side right over here, is congruent to SN, this side over there. So if SM is 10, SN is also 10. Okay, I want to find the perimeter. So the perimeter, I need to add up SQ, SR, and RQ. Okay, SQ right here, 10 plus 2, that's 12. Okay, RQ is 8. But SR, I have 10, but I don't know how long this is. So I need to look over here. This whole side was 8. If this is 2, how much is left? Yeah, 6. That means this is 6, and MR is also 6. So SR is 16 units long, or centimeters. So now we can find the perimeter. We can just add all of these up for the perimeter. So the perimeter is 36 centimeters. Make sure those theorems, you memorize them. They'll probably be handy for your note card for the test.